idea what a complex number is? Trisha?
It's a number that includes like one part a real number and then one part is imaginary.
Yes, so we'll talk about what imaginary number is. So, what is a complex number? Well, people thought of complex numbers when they tried to solve the equation x squared plus 1 equals 0. What would you get for x? Because if you solve it, it's like this. X squared equals negative 1. What are you going to do about that? So, in order to find a solution for x, they took the square root of both sides and they said the square root of negative 1 was the answer. And they called that I. So that is what an imaginary number is. It's just basically the square root of negative 1. That's what I is. So that's how they got those imaginary numbers, because they solved the equation x squared plus 1 equals 0 and they found a solution to that. But since this isn't really possible, they called it imaginary. So that's like the foundation of all imaginary number.
Stopping point is basically going to be nothing.
So, if we multiply I, which is the imaginary number, the square root of negative 1, if we multiply I by a real number like 2 or pi, we get a number like 2i or pi I. That is called a pure imaginary number. So, like something like 3i would be considered a pure imaginary number. And so you might see that term written in questions. It just means that it's some real number multiplied by an imaginary number. So the complex numbers are just pure numbers, pure imaginary numbers added to another real number. So it would be like, this is the pure imaginary plus like a constant. So that would be called a complex number. So those are just terms. So these are all examples of complex numbers. So yeah, everyone understand that so far. And the general form is always a plus bi, where this is a real and this is real, and yeah. And if you don't have, and if it's just in the form bi, you know that a is 0, and if there's just an I, you know that B is 1. Okay. So you sum imaginary numbers just like you do regular addition. So what would the sum of this be like? Treat I as a variable.
X plus 1 multiplied by
Like that. Yeah, so she just treated them as this is a variable, this is a variable, and she added the variables and she added the constants and kept them separate. So it's just like regular addition. So 3/4 plus 1/4. So if you had to find a general formula for this sum, like express this sum in terms of like what it would be, then it would be something like Z1 plus W1. That's like this is your process. So you add the constants and then you add the imaginary parts. So that would be, yeah.
So shouldn't that be 7 fourths?
Well, this is 1 actually. So 1.
3/4 not, or just 3/4. Shouldn't that be 7 fourths?
Oh yeah, sorry. Yeah, sorry. Like that. Okay. So 7/4. So does everyone understand that? Yeah, like how you just add it like regular. Okay. Okay. Now on to multiplication. Multiplication is a little bit different. You know how you use the distributive property for regular stuff? Like a plus b times x plus y would be what? Expanded out using distributive.
ax plus ay plus bx plus by.
Yes. So that would be what these are multiplied. So we're going to do the same thing for these. Okay, so Yeah, do the same thing, so what would this be?
Negative 9 plus
24i, just like regular. We're not considering, we're just doing it regular right now. 4i times negative 3,
negative
12i, just treat it as like a variable. And then 4i plus 4i times 8i, correct? So, okay, so you know this is equal to negative 9 plus 12i. And this is 32i squared, right? But what is 32i squared really? Because we have to express this, yeah. So I is the square root of negative 1, remember that? So what would I squared be?
negative 1.
Yes. So just replace the I squared with negative 1. You can't really do anything about this I, you just have to leave it as I because that's how you write it. This is an I squared. So it would be negative 9 plus 12i, and then what? Minus 32. We replace the I squared with negative 1. So that's why this is the answer. Well, and then you simplify it more, so it's minus 41 plus 12i. Does everyone understand that? So when you multiply, always look out for your I squareds and your I to the fourth to make sure it's in as simplest form as it can be. So you don't want to leave I squared in your answer. It's not a good thing to do. So what we got? Okay. Now we're going to divide complex numbers, which is a little harder than multiplication. So, okay. When we divide two complex numbers, we clear all instances of I from the denominator. So we want to basically, do you know what rationalizing the denominator is for squares? So yeah, we're going to do like a similar kind of strategy. So if somebody gave us 3 plus 4i divided by negative 3 plus 8i, and they said like simplify it as much as possible, then we would have to multiply this times 1 in the form this. So we're still multiplying by 1 because it's negative 3 minus 8i over negative 3 minus 8i, so that's 1. But we're basically getting rid of this, like taking I out of this because a plus b times a minus b is always a constant. So, does everyone get that? Like, why would you do that? To take I out of the denominator. So, you just multiply this straight through, so that would be negative 9, and then what? Minus 24i, minus 12i, minus 32i squared. That's the numerator, and then the denominator would be what? That would just be, yeah. Yeah, using the property that a plus b minus b. Or just distributing it out, so yeah. So then that would simplify to, what's negative 32i squared? That's also 32, yeah, because you replace I squared with negative 1. So negative 9 plus 32 is 23, minus 36i, over 9 minus, what's negative 64? Or what's negative 64i squared?
64.
Yeah, so plus 64. So that's how you get that. And then you just separate it out into parts to have the form a plus or minus bi. That's the form. So does everyone understand that, how you have to kind of like rationalize the denominator to get rid of the I? Because they don't like i's in the denominator. Any questions so far? Okay, so let's try this one. Okay, so what would the first step be? To multiply this thing by 1 to get rid of the I. What would we express 1 as? What would be here?
2 plus 3 over 4.
Yeah.
5.
So this is a minus b, this would be a plus b. And then this one is what? Yeah. So we just have to multiply that stuff out. what to do is we would just multiply this out. So negative 1/4 times 2 is what? Negative 1/2. Then what's negative 1/4 times 3/4? I squared, right? I'm kind of.
Wait, is
How's that?
right?
Oh, sorry. Yeah. I'm just gonna move it down here. So that was negative 1/2 minus 3/16 I. Then what else? You would do it with this one now.
Plus 2i. Plus 3/4.
And then the bottom.
4 minus 3/16.
Right? So we would now put that in numbers as much as possible. So we have negative 1/2 minus 3/16 I, we can't do anything about that, plus 2i. And what's 3/4 I squared? Remember, this is negative 1. Yeah, so it's just negative 3/4. And then this is 4 plus 9/16. So that equals, so what's so constants together, so negative 1/2 minus 3/4 is,
Negative 5.
and then negative 3/16 plus 2.
Plus 29.
Over 4 plus this. Okay. To write that in like a better reading, we can multiply like this, to get rid of the 16. So it would be negative 20 plus 29i over 73. That would be your answer. Alright, any questions? Again, the key was rationalizing the denominator. Or not rationalizing, but multiplying by the complex conjugate, which is what this is called. Yep. Any questions? Okay, let's move on. Okay, just going quickly over the graphing of imaginary numbers. So on the x-axis, there's always the real. You know how this is the real part, real, and this is the imaginary part. Yeah. So the real would be on the x-axis, so it would be a on the x-axis and b on this. So if we were given like 3 plus 5i, we would just basically plot the point 3, 5. Like that would be the complex number, except you would just do r, e, and I n instead of x and y. So yeah. And does anyone remember how to find the distance from like the origin to this? So if this was like A and this was B, using the Pythagorean formula, this distance would be what?
A squared plus 1.
Yeah. So that's often called the magnitude of a complex number, is your a squared plus y squared. So that's called magnitude. Okay. And now we're going to do like a fun, like this is what comes up a lot in competitions. Is the next slide. Is pattern. So they're always going to ask you like something like, what is I to the 250? And then you have to say what it is in terms of I. So, for example, let's try I to the 17th. Does anyone know a strategy about like how to figure that out? Yeah.
No, I just did. So if you like count from I, 1 to I to the 4th power, it just like repeats that. So if you can notice like the 4th, like that one has I to the 16th plus I to the 1. So that's I to the 2.
Yeah, so what Gordon is saying is that there's a pattern. So I to the 1 is always I squared is -1, I cubed is -1 times I, so it's negative I. and then I to the 4th is this squared, so it's 1. So these, and then I to the 5th would be what? Again, I. I to the 6th would be -1, so it repeats every 4. So if it repeats every 4, then what would that one be? So what this one would be was the first 4, so I mean like this is out once, like this pattern's out once. And then we have I to the 13th left. Then another one of them is out, like these 4 went through, so it's I to the 9th left. And then another one goes and it's I to the 5th left. And then another one goes and it's I to the 1, so that's the answer. Because it has gone through 4 cycles, because the power is 17. You divide by the cycle count. So it's gone through 4 different cycles with a remainder of 1. So it's completed it 4 times, and then it's like 1, 2, 3, 4, 1, 2, 3, 4, and then it comes back to this one. So that's why the 17th one in the pattern is I. So let's try I to the 69th. Does anyone have an answer for that one? Yeah, it's I. Because 69 divided by 4 is 17 remainder 1. So it's gone through 17 cycles and it jumps back to this one. So that's how you figure out like big ones.
So there's going to be 4 teams. So one team will be 1, 2, 3, 4. Second team. Third team here. And then 4th team.
Do you want to order?
Ready for it to go over? Okay. So for this one, this would just be equal to -1 times -3 times -11 times -61. The negatives all cancel, so it's actually just, you're working with positive numbers. So that's just the square root of 2013 when you multiply it out. Okay, so that was number 1's exercise.
Janina Pelzer, please report to the front atrium.
You come over here, and you place square root of 2013 right here. So you would get what?
1 to the 2013.
That equals I with the pattern. Okay. And then this is number 3 and 4. So we got what from we got I from number 2. So we would replace K with I. So if you expand this out, you should get. So this is just like a brute force of expanding. So that's 3i squared plus root 3i plus root 3i. So it's plus 1. That is -3 plus 1, -2 plus 2 root 3i. Multiply that by another one of these because it's 2. So root 3i plus 1. So -2 root 3i minus 2 plus 6i squared plus 2 root 3. So that's, I forgot that. So that's, these cancel. So it's -2 plus 6i squared, which is -2 minus 6, which is -8. So that was number 3. So then you come and plug -8 into here. Okay, so -8 divided by 2 is, negative of -8 divided by 2 is what? 4. So this one is 4 minus 10i, and this one is 7 plus 3i. So you would plot them really quick. So like this would be 4 -10 right here. And then this would be 7 plus 3i, somewhere over here. So 7, 3. Because remember, this is real, this is imaginary. And you have to find the distance between these 2 points. Okay, how do we do that? That was the trick, basically. So does anyone remember the distance? Yeah, the distance formula. So what's the distance formula? I don't know. Yeah, because basically, like, you're kind of like forming a right triangle. This is this isn't drawn very well, but, okay, so x2 minus x1 squared is what? Is 3 squared, so that's 9. Y2 minus y1 is 13. That will give you the square root of 178. Yeah, okay. For number 1, you know that I to the negative 18th is 1 over I to the 18th? Because that's a property of exponents. Okay, so using the pattern thing, what's I to the 18th?
-1.
Yeah, because it's I squared. This one is,
I.
right, this one is 1. This one is,
1 over I.
1 over I.
and this one is 1 over negative 1.
Just
So,
negative.
Oh, I get worried.
Negative 1 plus I plus 1 over I. That's what we shall do.
So it's negative 1.
yeah,
Huh?
yeah, so it's,
Ow.
So negative 1 plus 1 is 0.
Yeah, it's
1 over
Yeah.
I plus
Yeah.
I is equal to.
yeah,
How's that equal to 0?
yeah. So,
Did
yeah,
you
so
get the
then
answer?
it's 1 over I plus I minus 1.
Oh, okay.
Yeah.
I see.
Okay, so the answer you should have gotten for that is negative 1. And then,
Is that a
you come over here, put negative 1 in for k. So then you have negative 5 root 18 over negative the root of negative 45. And that's the same thing as when we simplify the denominator, it's I times root 45. Agree? Because I is, yeah. So that would equal negative 5 root 18 over I times, what's root 45 simplified?
3 root 5.
Yeah. So that's 3 root 5. Then we can also simplify the numerator. What's root 18 simplified? 3 root 2. So we have this. Anything we can cross out? You can cross out these. Then we can rationalize. So you can do so that's negative 5 root 10 I over 5I squared. These cancel, and so it's root 10 I. I kind of went through that fast, but I just had that, then I rationalized it, and I multiplied through, and then I, yeah. So then this is 5I squared, which is negative 5. Then you cross more stuff out. So mostly with complex number problems, you just have to make sure your algebra is right. Okay, so we got an answer of I root 10 for number 2. So what value of b would we use here? Like this. Yeah, because we got an answer of I root 10, which means b is 10. So we take that value of b and put it in here. So 10 over 2 is what? 5 times 1 plus I over 3 minus 4i times 2 times 5, 20, sorry.
It's
And then-
That's a plus.
Would it messed up? Okay, so, okay, instead of adding these two like as a common fraction, you can simplify this one first because it's just going to be so complicated if you do it in one. I mean, you can try it, it's just going to be so much harder. So first we're going to rationalize this side to get it into a better form so that I is not in the denominator. So 5, so this would equal 5 plus 5i over 3 minus 4i. We would multiply each side by 3 plus 4i. And that would equal 15 plus over 9 minus 16i squared, so, right? So that would be 35 minus 5, 35i minus 5 over 27. And
25.
Yes,
Wait.
5.
so that was number 3, okay. Yeah. So then you take a 5 out, so it would be 7i minus 1 over 5. Right.
That's right. That's the first part.
Well, there's another part. That's what I forgot. Okay, sorry. Okay, so this part. Same thing. So, what would we multiply each side by?
4 minus 3.
This one's easier. Four minus 3i.
It's going to be.
I'm just going to.
Yeah, 4 during first period.
It was first grade.
Number 1 weekly. I went 13 minutes before the
Okay, so when you get 3 minus I as number 3, you just plug this in here. So, you plug this in here, you do the same thing. You would rationalize again. So, number 3 was
No, it's because I accidentally dropped the 5. And that's what
Yeah,
happened.
the whole number.
No, it was gone. I did 5 plus I instead of 5 plus 5. Yeah. You added the whole number?